Well, let's do a review of the numbers we've looked at so far. We're going to look at nibbles, so that's 4 bits. So unsigned numbers go from 0 up through 7. 5 is our number. We have signed magnitude numbers. 101 is our number for binary, but in this case 101 is going to be a negative number, and it's a -1. Basically, you take the first bit, and that's the sign, and then you look at what's after that, and that's the number. There are two numbers, ways of writing 0. That's all zeros, or 1 and 2 zeros. 1's complement, 101 is also a negative number. This time it's -2. And 1's complement, to negate a number, you just flip all the bits. 2's complement is actually what we use most of the time, or almost all the time. You know, it goes from a range of 3 to -4, and 101 is a -3 in that case. So these are the numbers. 101 base 2 is 101, 5, unsigned, -1, signed. 1's complement's -2 and -3, and 2's complement. So what if we had a nibble that's 4 bits and we wanted to extend it to 8 bits? In 2's complement, it's very easy to do that. You can extend the number of bits wider by just replicating the leftmost bit, make it as big as you like. For example, what's the decimal value of the 2's complement number 0110? Well, the leftmost bit is 0, so you just add as many zeros to the left as you want, and it's still 110, which is 3. No, which is 5. What is it? 6. And 111, let's check that out to make sure a negative number works. If you just extend that 1 right on the left, the leftmost one, just to put as many more ones as you want in front of that, and it's still -1. So there we have it. So what about converting from decimal to binary? Basically, one way of doing it is you continually divide the number by 2 and prepend the remainders until 0, and then the remainders are your number. So suppose we take the number 43. We want to convert it to binary, so we divide it by 2. 2 goes into 43 21 times, with 1 left over. So we have 21, remainder 1. So we put that R1 out there, and we put the 1 over here as the first digit of our binary number. Now we have 21. We need to divide into that. 2 goes into 21, goes in 10 times with a remainder of 1, so this remainder 1 right here gets put in the second position right out there. Then we go 2 into 10, which goes in 5 times with a remainder of 0, so we put the 0 right over there. And then we do 2 into 5, which goes in 2 times with a remainder of 1, so we put the remainder of 1 right over here. And then 2 into 5 goes in 2 times with a remainder of 1, so. And then we do 2 into 2 goes in 1 time with a remainder of 0. And so, no, 2 goes into 1 0 times with a remainder of 1, so you put a 1 on the end. So here's your number, 110101. I got it backwards. Is that right? 110101. So I've got it backwards. You start counting down here. This is the highest bit, and that goes to the lowest bit. Okay, so Another way of doing this is looking at things like, what is the highest number of 2? 2 to the what has the highest number that'll go in there, and probably 32 is the biggest one, and that'd be 2 to the 5th. So I can see I've got 132 in there, so that's this 1, that 132. And then what's left, think about what's left, difference 32 and 43 is 20, well, not 21. What is the difference in 32 and 43? That's 11. So how could I write 11? Well, this is 11 here, 1, 0, 1, 1. And you could kind of do a similar kind of thing there. So there's several ways to convert between decimal and binary, or decimal to binary. And you prepend a 0 if you want 8 bits, or you prepend as many zeros to get as many bits as you want. If you need the negative number, you do the 2's complement of that number. So here's a quiz for you. I'll let you look at how to do this, see if you can figure out how to do 5, 123, and minus 35. Shouldn't be too hard.